Here we're told an isosceles triangle has a perimeter of 32 units, and they're giving us the vertices. So they're giving us some points here, but there's no picture. When they do that, I definitely recommend that you at least sketch the picture, sketch these points, so you have a better understanding of what you're being given, what you're being asked for, and then how to figure out the answer. So first, let's plot point J and K, since they're giving us both the X and Y coordinates of those points. Now the third point of the triangle, they're just giving us the Y coordinate. We don't know how far we're going to the left and right, but we do know that we're going to go down negative 1.5. So I'm just going to draw a yellow line here at about negative 1.5 and know that the third point is somewhere on this line. Now, they're also telling us that this is going to be an isosceles triangle, and isosceles triangles have two sides that are the same length, the same measure, and also two angles that are the same measure, diagonal from those. They're also telling us that the perimeter is 32. So that means if we know the length, the distance of each of these three sides, and add them together, they're going to add up to 32. So distance. What is the distance? That leads me to ask myself what the distance is between J and K. So I'm just going to draw a line there. Now, distance can be found between any 2 points using the distance formula. However, when you have a vertical line like this or a horizontal line, you can just count how many unit blocks are between those 2 points. So it goes down to -9, up to 6, so that means it has a distance of 15. So let's use that then to figure out the distance of our other two sides. If this is 15, and the other two sides in 15 add up to 32, what are the lengths of those other two sides? Well, 32 minus 15 is 17. So those other two side lengths have to add up to 17. And if those two side lengths are the same size, let's divide 17 into 2 equal parts. So each of those side lengths is 8.5. So now let's make a more complete sketch. We know it's not too big, it's about 8.5. I'm just going to guess about here. So this is approximately where our third point could be. This is our L. So we don't know the X coordinate, but we know it goes down -1.5, and we know the distance of these two sides now is 8.5. Now we're going to use the distance formula. Let me write that down. Now, the distance formula isn't something you have to memorize. It'll be on your formula sheet, but we're going to use that and just kind of pick one of our lines. Let's pick the KL. We're going to use those 2 points and then the distance of 8.5. So first step is to label the points. Let's call this X1, Y1, and this X2, Y2. So really try to ignore the rest of it and focus in on those 2 points. I'm going to erase the rest of it. So I just erased that so we can really just focus in on this line in these numbers. You might want to just draw a separate little sketch of the line with just the numbers that you're concerned with. So now let's substitute the numbers into the formula. Now distance, we're not calculating the distance. We already know that it's 8.5. And then square root X1 is -3, X2 we don't know, so I'm going to leave that as X2. Y1 is 6, Y2 is -5, so we're going to subtract -1.5. Now remember, subtracting a negative is the same as adding, so I'm just going to change that to plus. And now we simplify some more. So I'm going to say 8.5, and I am going to just simplify 6 plus 1.5. 6 plus 1.5 is 7.5. So this is 7.5 squared. What is 7.5 squared? I'm kind of simplifying more than one thing at a time here. That's the same as 56.25. So if I look at the right side, there's not much else I can do right now because I can't move anything out from underneath that square root. How do I get rid of the square root symbol? What is the opposite of square root? Square. So let's square this side and square this side. Here we get 72.25, and on the right side, all it does is eliminates the square root. Now that the square root symbol is gone, we can move that 56.25 to the other side. So if we subtract that from both sides, what do we get? 16. Now again, I can't move anything away from that x2 anymore because it's cupped in parentheses and the whole thing's being squared. So how do I get rid of the square? The opposite of squaring is square root. So let's take the square root of both sides, and we have -3 minus x2. And on the left side, we have not just 4, but -4 as well. So it's either positive or -4, because -4 times -4 is 16, and +4 times +4 is 16. So now we're going to separate that plus or minus and make two separate equations. So either +4 equals -3 minus x2, or -4 equals -3 minus x2. So if we solve each of these, we see that that missing x coordinate can be either -7 or 1. So why are there two different answers? Here's one of our solutions. So again, this is 15, 8.5, 8.5. So it's an isosceles triangle. And the sides add up to 32. Or it could look like this. So this one also is an isosceles triangle. It's just going in the opposite direction. It also has a perimeter that adds up to 32.